Today we are going to be talking about inverse trig functions. By the end of this video, you should be able to understand and use the two symbols for inverse trig functions, and you should be able to find the exact values for inverse trig functions. So first, let's start with sine. So we're going to take a look at the graph for y equals sine of x. So using our standard way to label the axes, we have negative pi, pi, 2 pi, 3 pi, 1, and negative 1. So the sine curve we know starts at 0, and I'm going to go ahead and continue this pattern. So if I connect these points, here is my sine curve. So here we have our sine curve. If you remember what we talked about earlier in the year when we discussed inverses, a function must be one-to-one to have an inverse. And we check to see if a function is one-to-one by doing the horizontal line test. So if I draw a horizontal line through my graph of y equals sine of x, I'm going to hit the graph either 0 times or infinitely many times, which means that the graph of y equals sine of x is not one-to-one. But we can talk about the inverse on a specific part of this graph. So this section of the sine curve is one-to-one. So when we talk about the inverse sine function, it can only be on this part of the graph. So there are a couple ways that we can write the inverse sine function. We can do y equals sine inverse of x, or we can say y equals arc sine of x. Both ways are acceptable, and they are both asking y is the angle whose sine value is x. Or what angle has a sine of x? So because we are only looking at part of the graph of sine of x when we do the inverse, if we look at the unit circle, we can only talk about inverse sine between negative pi over 2 and positive pi over 2. So that is this part of the unit circle. And this does include negative pi over 2 and positive pi over 2. So we say that inverse sine of x is between negative pi over 2 and positive pi over 2. So let's look at a couple of examples. If we want to know what is the arcsine of negative 1/2, we need to first think about the unit circle and think, where is sine negative 1/2? Well, that would be here and here. But we said that inverse sine or arcsine is only defined on this half of the unit circle, which means that we are going to ignore this value and just look at the point that is between negative pi over 2 and positive pi over 2. So on the unit circle, this angle would be negative pi over 6. Problem number 2 says inverse sine of square root of 3 over 2. So again, let's look at the unit circle. Where is sine square root of 3 over 2? Remember that sine is the y value, so that would be here and here. But we only want the angles between negative pi over 2 and positive pi over 2. So we're going to ignore this angle and just have this one, which is pi over 3. Lastly, we have inverse sine of 2. If you think about the unit circle, where is the y value 2? Well, that never happens because sine of x is always less than or equal to 1. Just remember that sine is between negative 1 and 1. So this will never happen. So we say that it is undefined, or that it is the empty set. There is no angle that has a sine of 2. Let's go on to cosine. So I'm going to start with a graph of y equals cosine of x, labeling my axes in the standard way. So we have our points for y equals cosine of x. And then we just connect the points. So here we have the graph of y equals cosine of x. Again, this graph in its entirety is not one-to-one, but we can look at a part of the graph that is one-to-one, and that would be this part here from 0 to pi. So again, there are two ways of writing inverse cosine. You can do this or arc cosine of x. And both of these mean y is the angle whose cosine is x. So again, let's take a look at our unit circle. Since we are looking at the part of this graph between 0 and pi, that means that we are looking at this section of the unit circle. And we are including both 0 and pi. So this means that inverse cosine of x is always between 0 and pi. Let's look at a couple of examples. We have inverse cosine of square root of 2 over 2. So let's look at our unit circle. Remember that cosine is the x value. So angles that have a cosine of square root of 2 over 2 are here and here. But since we are only looking at angles between 0 and pi, we are excluding this one, which is negative pi over 4 or 7 pi over 4. And our only answer is pi over 4. If we want to find arc cosine of negative 1, we want to know where on the unit circle is cosine negative 1. Well, x is only negative 1 at one point, and that point is pi. So this is just pi. Next, we have inverse cosine of pi. So where on the unit circle is cosine pi? Well, pi is bigger than 1. We know that cosine is always between -1 and 1, so this never happens. So this one is the empty set. Lastly, let's take a look at inverse tangent. We have y equals tangent of x, and we label our axes in the normal way. We know that the graph of tangent of x has asymptotes at -pi/2 and +pi/2. And then our curves for tangent of x occur between those asymptotes. So there we have our graph of y equals tangent of x. Again, the entire graph is not 1-to-1, so we're going to look at one period that is 1-to-1. We're going to look at this part of the graph here between -pi/2 and +pi/2 because this piece is 1-to-1. Again, we have two ways of writing inverse tangent. We have this way, and we have arc tan of x. Both mean that y is the angle whose tangent is x. So if we take a look at the unit circle, that means for inverse tangent, we are looking at this part of the graph between -pi/2 and +pi/2. But since we have asymptotes at -pi/2 and +pi/2, we have open endpoints and are not including -pi/2 and +pi/2. So inverse tangent is between -pi/2 and +pi/2, not including the endpoints. If we want to know inverse tangent of 0, we look at our unit circle. Remember that tangent is sine over cosine. So if we have that tangent equals 0, that's the same thing as asking where does sine of x equal 0. And that only occurs here at 0. If we want to find arctan of -8.45, that is not on the unit circle, so we have to use our calculator for that. So first, you need to make sure that your calculator is in radians, which ours is. Then all of the inverse trig functions are typically right above the trig function, so you can see it has inverse sine, cosine, and tangent. So we can just do inverse tangent of -8.45. And we get, rounded to 3 decimal places, that this is approximately -1.453. If we look at inverse tangent of square root of 3, This takes a little bit more thinking. To get that tangent is square root of 3, you've got to think about what is sine and what is cosine for the tangent to end up being square root of 3. To end up with square root of 3 as your tangent, you would have to have square root of 3 over 2 as your sine and 1/2 as your cosine. And that occurs at pi over 3. That also occurs over here at 4 pi over 3, but that is not between negative pi over 2 and positive pi over 2. So we'll just ignore that one. Similarly, when we are looking for inverse tangent of square root of 3 over 3, we have to think how that would happen. And that's going to happen when sine is 1/2 and cosine is square root of 3 over 2. So thinking about the unit circle, that's going to occur at pi over 6 and 7 pi over 6. We only want the one that is between negative pi over 2 and positive pi over 2, so we just want pi over 6. Now let's look at a couple more complicated examples. If we want to know the tangent of arctangent of negative 5, we could find the angle with a tangent of negative 5 and then take its tangent, but we'll just end up at negative 5 again. So these are inverse functions. We end up with negative 5. Number 12 is a little bit different because first we are taking the sine of 5 pi over 3. Well, if we look at our unit circle, 5 pi over 3 is here. So sine of 5 pi over 3 is going to be negative square root of 3 over 2. So we want to know what is the inverse sine of negative square root of 3 over 2. Now, if we want to know what the inverse sine of negative square root of 3 over 2 is, both of these points have a sine of negative square root of 3 over 2. But inverse sine only goes from negative pi over 2 to positive pi over 2. So the angle within a sine of negative square root of 3 over 2, that is between negative pi over 2 and positive pi over 2, is negative pi over 3. This is not the same angle that we had at the beginning. It is the coterminal angle of 5 pi over 3. So yes, the sine and the inverse sine still kind of cancel out, but we get an answer that is between negative pi over 2 and positive pi over 2 and is coterminal with our original angle. Here we have cosine of cosine inverse of pi. You would think that the cosines cancel out, but cosine never equals pi. Cosine always gives you a value that is between negative 1 and 1. So this part, cosine never equals pi. So there is no answer to this problem. Lastly, let's look at tangent of arc cosine of 2/3. Well, 2/3 is not a value that's on our unit circle, so let's draw a triangle. We know that arc cosine always gives us a value that is between 0 and pi, which means that we are only looking in quadrant 1 and 2. Cosine is positive in quadrant 1. So we're looking at a triangle that is in quadrant 1. We know, thinking back to SOHCAHTOA, that cosine is adjacent over hypotenuse. We need to use the Pythagorean theorem to find the other side. So we have 3 squared equals 2 squared plus y squared. And we get that y is square root of 5. So then we just need to know tangent of this angle. We're thinking back to SOHCAHTOA, tangent is opposite over adjacent, so we have square root of 5 over 2 as our final answer.